question can you do?
I only can do
Only question one. It's okay, it's okay. I can only do question 4.
wait. I only can do question 2.
Stop, because I can only do question 4.
So each of us only can answer one question only.
Yes, which means if we combine our brains, we can actually survive this exam.
Oh, we are lucky smart.
So instead of crying like a drama queen, let's teach each other.
Let's highlight the important thing that the question wants. There are three types of boxes, P, Q, R. Each use different amount of material which is cardboard, plastic, and foil. The first question, form the system of equation. Box P represent X, box Q represent Y, and box R represent Z. To know where is X, Y, Z, we have to look at the table. Column 1 as X, column 2 as Y, and column 3 as Z. Cardboard is for equation 1, plastic is for equation 2, and foil is for equation 3. Next, just write an equation using those information. So we know that the first equation represents to cardboard, and second is represent to plastic, and the third is foil. Now let's do the question B. We're using this formula. Label for each equation to avoid misunderstanding. Put the number in the matrix column. For X, we just take the X, Y, Z. Last but not least, just put everything we know in the equation. Make sure follow the formula. Question C, inverse matrix method. Step 1. Find determination of A. Use cofactor expansion along the first row. Calculate each cofactor by finding 2 multiple 2 determinant. Step 2. Find matrix cofactor by using this step. Step 3. Find adjoint A. We have to find minor A to get adjoint A. Step 4. Inverse matrix. Use the formula to get inverse matrix of A, -1. Final step. Put in formula A -1B. So this is our final answer. Yay!
Assalamualaikum. My name is Nur Arifa Umaima and I will be presenting the application of the matrix inversion method to solve a system of linear equations based on a herb watering schedule. In this question, we have given a table of water usage rate for 3 types of herbs over 3 days. The total water used for each herb over 3 days is known. Our objective is to determine the exact amount of water used on each individual day using the matrix inversion method. The first step is to write the matrix equation. We begin by identifying the coefficient matrix A, the variable matrix X, and the constant matrix B based on the given water usage table. Matrix A represents the water usage rates per day for each herb. Matrix X represents the unknown total water used on each day, and the matrix B represents the total water used for each herb over 3 days. The second step is to find the determinant of A. To find the inverse of matrix A, we must first calculate its determinant. We expand along the first row. Since the determinant is not equal to 0, the inverse of matrix A exists and we may proceed. Next, step 3, find the cofactor matrix. We calculate each cofactor by finding the 2 multiply 2 determinant of the remaining elements after removing the corresponding row and column, then applying the checkerboard sign pattern. Step 4 is to find the adjoint matrix. The adjoint matrix is obtained by transposing the cofactor matrix, meaning we're going to swap the rows and column. In this case, the cofactor matrix is symmetric, so the adjoint is identical. So the step 5 is to find the inverse of A. The inverse of matrix A is calculated using the formula 1 over determinant A multiply adjoint A. By substituting the value, since the determinant equals 1, A inverse equals the adjoint directly. Finally, we're gonna multiply the inverse of A by matrix B to find the values of x1, x2, and x3. For x1, which is day 1, we're gonna got 80 liters. For x2, which is day 2, we're gonna got 40 liters, and x3, which is day 3, is 60 liters. Based on our calculation using the matrix inversion method, the total water used on each day was day 1 is 80 liters, day 2 is 40 liters, and day 3 is 60 liters. These values satisfy all 3 original equations, which confirm that our solution is correct. The matrix inversion method has proven to be an effective and systematic approach by solving this system of linear equations. Thank you.
For question 3a, imagine that we have 3 big orders coming in. So we got 1 thyme plus 1 lemongrass plus 1 lavender equal to 210. For order 2, 2 thyme plus 1 lemongrass plus 1 lavender equal 250. Order 3, 1 thyme plus 1 lemongrass plus 2 lavender, which is 280. This is the answer for question 3a. Question 3b, we must set up matrix form first, like this, and find the main determinant, which is delta 0. Find the main determinant, we must copy the matrix that we have created earlier. The next step is like this. Copy here. Next, we must multiply. Multiply like this. So you get like this. Next, we need to find delta t. The method is almost the same as before, except we replace the first column with the constants. To find the delta g, we must replace the second column with constants. The same goes for delta l. Replace the third column with constants. Next, we must divide each delta by delta 0. So the final answer, we need 40 packs of thyme, 100 packs of lemongrass, and 70 packs of lavender. Orders are ready.
Hi everyone, today I will solve a plant nutrient mixing of problem using Cramer's rule. My goal is to find the exact amount of 3 nutrients, N1, N2, and N3 used in 3 different mixes. First, I will turn the mixed detail into a system of linear equation. For the first mixes, we have n1 plus n2 plus n3 equals to 240. Next, we have 3n1 plus n2 plus n3 equals to 320. And the last one, we have n1 plus 3n2 plus n3 equals to 340. Next, I need to find the main determinant, which I call its A. I take the coefficient from the equation and put them into a matrix, like this. And after calculating, I will find the determinant is 4. Now, I calculate the specific determinant for each nutrient by replacing one column at a time with the total value. For the determinant of n1, I got 160. Next, for the n2, I got the determinant of n2 is 200. And lastly, for the n3, determinant of n3, I got the determinant of 600. Finally, I divided each result by the determinant, which was 4. For n1, I got 40, n2 I got 50, and the last one, n3, I got 150. So, in conclusion, the gardener used 40 grams of n1, 50 grams of n2, and 160 grams for n3. That is how I use Cramer's rules to solve this problem.
Now we understand all the questions. We can complete the assignment and submit tomorrow.
Yay!
La Banana al